Hello. Hi, everybody. I wanted to talk to you about good morning. Happy Monday. I don't know if we can have happy Mondays. So, like, yay, it's Monday. um, but in any case, I hope you're looking forward to the school week. We have a couple new students coming in for my class today, which is awesome, that I haven't seen in a little while, which is cool. I hope you guys are all looking forward to finishing off our last week before progress reports, right? This is it. This is the week before progress reports. They're due this week. So try to catch up on your grades. I'm sure all your teachers have told you that, but I'm telling you that. I'm telling you that. I'm telling you that. Do your Khan Academy. I'm telling you that too. So do all of that stuff this week as much as you can. I've been grading things, but I'm going to keep grading things. And the more that you do, the better off you will be in your grade. Hey, I've got some visitors here. Hi, guys. So you want to say hi?
Who are those people?
There's Leah. Say hi. Okay, now you, and then Stacy, do you want to say hi?
Beautiful hair. Who are those?
This is my, I'm doing my video for my students. Okay, I'm going to finish. You want to say hi? This is Stacy and Leah. Say hi. They just had a dance performance today. These two did. And I'm sure some of my own students did as well. Okay, now, they've been outside the entire time. As soon as I start the video, they're like the cat. As soon as I start the video, they come in and they want to be in the video. It's bizarre. Okay. In any case, I want to talk to you today about surface area. The idea of surface area is that almost everything that we look at, everything that we have in our house, not everything, but all the packaging we have is made of a lot of times boxes, right? So this is like a tea box. I don't drink this tea, but my wife does. And this is made of a surface. It's a net. It's made of a certain amount of material to make the box, right? So when I look at this, right, I think, okay, I don't think this, but if I was looking at this from a kind of business perspective, I'd be like, how much material do we use to make that box? Is our box efficient? Does it kind of like, hold what we need? And in here, I'm going to show you what this thing holds. This thing holds tea, right? So, and I think it's packed pretty full. They don't like slam it in so full that, it's going to get all this, or that you got all this empty space. But, they put the tea in. I'm going to show you like this. Right, and there's like 20 packs or maybe 25 in here. Let's see, 20. There's 20 in here. Right now there's only about 8 left. But the idea is that this fills, they use this pretty efficiently. One tea bag fits in pretty evenly on the side of this thing, right? So they have these people that would make their packaging, that would design it. And they might look at their packaging and be like, okay, how much material do we need? How much cardboard? Thin cardboard do we need to make this box, right? And if you have to make like millions of these boxes, you're selling millions of bags of tea all over the country, you might want to save some money and save some energy and save some trees by making your box smaller, or as small as it can be, and still do the job, right? So this is a Tazo tea box, right? And it's got a net. So how much material you use and how big your box is a function of surface area, and it's a function of the net, right? And the net means when you take it apart, it opens up into something. Now, same thing. I got a Lego thing here. I just went around my house and collected stuff. This looks like an older Lego kit, right? Once again, put in a box, right, with all the ads on it. But this box has 6 sides, right? Much like this box. These are called rectangular prisms. They have 6 sides. And when a company makes these, they make a decision about how big they need to make the box in order to get attention, in order to sell it, right? I want to sell something in a box. If it's so small that nobody sees it, I'm not going to be able to sell it well. But if it's the right size, people will see it. They'll maybe want to buy it. If it's too big, think about your Amazon or your packages that come. And sometimes you get this little tiny thing and it comes in a giant box. So wasteful, right? Like that's very wasteful when Amazon sends us like one thing or 2 little tiny things and they're in this giant box with all this packaging. It's really dumb, right? So obviously they, in a lot of cases, they haven't figured out this idea of being efficient with their boxes, being efficient with their shapes, right? So what we're going to talk about today is surface area. The surface area is the amount of area, right? We've been talking about area in our classes. The amount of area that covers a shape or covers a 3-dimensional shape. So this thing has a surface area, and the people that would design the packaging would talk about surface area, and they talk about how big is this? Is it efficient? Are we wasting money? Are we using too much material? Are we making our boxes too big? Or they might say, are our boxes too crowded, where when we open it up, we can the consumer can barely get the tea bags out because they're packed so tight. So they think about those things. But surface area then matters in the sense of efficiency. And if we are efficient with how we package things, then we waste less. And we also can, if you're running a company, you can save money. So wasting less, saving more money, right? Like those are two good things. And the big thing for me is wasting less, right? So I'm going to show you how that works. So when we figure out the surface area of something, we are often looking at like a cube or a rectangular prism. This is a rectangular prism. A cube is like a Rubik's Cube, right? I can't believe I don't have one sitting around. My son always has them around, but not right now. But a rectangular prism, or a cube in this case, has 6 sides. So you can see them here. And on those sides, those surfaces, we have a top and a bottom. We have a side A and a side B, or side 1, side 2, and a front and a back. Notice that the pairs of sides that are colored the same, like the top and the bottom, are not next to each other. They don't go next to each other. They're top and bottom. They're separated by something, right? The sides, orange and orange here, are separated by a couple sides in between. Like if you think about this side over here and that side on the other side, the opposite side of it, it's separated always by either a top or a front, or a back or a bottom, right? So our sides are always set in pairs. It's always about a pair of sides, right? A pair of top and bottom, a pair of front and back, okay? So in order to find the surface area, which is abbreviated SA, surface area, it's really complicated, right? I'm thinking I had to explain that for you guys because you might not get it, right? Surface area, tricky. Okay, so you have to find with a cube, which like this drawing is a cube, everything is the same. It becomes really simple. You find the area of just one side, which is your length times width, or your base times height. And once you find the area of one side, for instance, this one side, my bottom on this drawing, is 3 centimeters by 3 centimeters. Then I know it's 9. 3 times 3 is 9. My area is 9 centimeters squared. And to find my surface area, I just say, oh, all 6 sides are the same. So 9 centimeters squared times 6. Times 6 sides, right? And that gives me a surface area of 54 centimeters squared. Now, really important, with surface area, the measurement is still in squares because we're measuring basically flat squares. Like when I'm measuring it, I can't say if you can tell that that's graph paper, but I'm measuring it with graph paper, or I'm measuring it with a graph layered over my surface, right? I'm not talking about the volume. Earlier in the year, we talked volume. Volume is how much space it holds inside, but surface area is how much it takes to make this net, meaning the net being when I unfold this box, it makes a net, right? So that is what surface area is. So in this case, the other way we could do it is we could say 9 plus 9 plus 9 plus 9 plus 9. 1 for each side. So if the back is 9, the front is 9. If the top is 9, the bottom is 9. If the side is 9, the other side is 9. And you go 9 plus 9 plus 9 plus 9 plus 9 plus 9. But we've talked about this before. Repeated addition is the same as doing multiplication. So you might as well multiply. 9 centimeters squared times 6 sides equals a surface area of 54 square centimeters, right? So it's a measure of how much cardboard are you using to make a box, essentially. That's kind of what it is. So you need to take this note down, write it in your notebook, and then we're going to do a couple other things today. This might end up being a little bit of a long video. So if you need more time in this, you can pause it now. If your teacher wants to pause it, great. Take a little more, another minute to do this, fine. And then we're going to move on to the next slide. Here we go. All right, the next slide is going to be this one. Now, I got to move my head a little bit here. Maybe I'll just move this up. All right, now what's interesting on this is I want you to see if you can figure out the matching here. This is a matching situation. And the idea is that I am matching the net. So the top blue ones are nets. And let me get my pencil out, or my pen. And let's talk about these nets, right? So this one right here, these are all the nets. So up here is what we call the nets. And the nets just means when we unfold something, what does it make? So these are our nets, okay? These are our nets. And these down here are the 3D, three-dimensional solids, right, that they make. So this idea of the 3D solids means that those nets wrap together or fold together to create these shapes. Yeah, it's like my bubbles. They create these shapes. Now, what I want you to do is think about, right now, I want you to pause the video. And I want you to, well, not right now. I want you to look at the nets A, B, C, D, E, and F, or A, B, C, D, E, and match them to the shape that they would make. So 1, 2, 3, 4, 5. Okay, I would like your teacher to pause it now and see if you guys can talk it through and figure out which is which. All right, I'm back. It's funny, when I pause it, I actually pause for like a minute. And it's funny, like there's no reason for me to pause it for a minute while I'm waiting. You guys can pause it, like no reason for me to pause it, but I pause it for a minute and sit there and like, that was dumb. Okay, so matching, what do you think? I'm guessing you figured this out. But what I want you to notice is that a couple of these had 6 sides, right? E and B have 6 sides. So we're looking at basically 1, 2, 3, 4, 5, and 6. And over here, 1, 2, 3, 4, 5, 6. So those two both are much like the one we had in our drawing, or the ones I'm showing you. They are rectangular prisms. One of them is a cube, though, and this is where the matching comes in. So this one, number 1, right here, is a cube. Notice that all the sides are the same. So we're going to call this one a cube, right? Number 1 is a cube, and that means this, right up here, this E is a cube. It's number 1. So we're going to say cube, and we're going to say number 1. I'm guessing you guys got that one. Now, of the other ones, 6 sides, I'm looking at number 2, and I'm looking at B, and I'm like, this is the only other one that has 6 sides, right? A front to back, a top, a bottom, a side, and a side. So we're going to say this one is a rectangular prism. So these two go together. B and 2 go together. So we'll put an arrow to those two, right? And we're going to call this one, and I'm going to abbreviate, but it's a rectangular, maybe I won't abbreviate, maybe I'll try to write it all in, rectangular prism, right? And all that is like, it's like a cube, but it's extended because it's got a rectangles on the, these are not squares, they're rectangles, right? So it's a rectangular prism. So B is 2. So we're going to say B is 2. Okay, so now we look at the next one. Let's look at down here. I'd say look at number 3. Number 3 is a pyramid, like the Egyptian pyramid. So we're going to call this a pyramid, right? But there's something interesting about this. This is a pyramid, but also this is a pyramid. Oh my gosh. So these are both pyramids. So what's the difference between them? Well, this one has a square base. So what we're going to do is actually call it a square pyramid, right? A square pyramid because it has a square base. And this one we're going to call a triangular pyramid, all right? So a triangular pyramid because it has a triangular base. I don't know if you guys can see that, but this part down here is a triangle, right? And that's a triangle base. So this is a triangular pyramid, and this one has a square base. So it's a square pyramid. So which one goes with which? Well, you might have already figured this out, but the triangular pyramid then must be this one, right? So we're going to go up here and say this one's number 4 because look, it's made of 1, 2, 3, 4 triangles. This one up here, if you look at it without my sketching on it, you can kind of see that it has 3 sides, 2 that you see, 1 behind, and then 1 in the bottom. That's 4 sides, all of them being triangles. And this one over here is the same, except that it's got 4 sides that are triangles, right? 1, 2, 3, 4 that are all the same. And then it's got a square base. So a square pyramid, right? And so this one must be number 3. And I'm guessing once again you knew that. And then the last one has to be this one. And what this is called, and we're going to just do an arrow. Why not? We'll just do an arrow here. Should probably do arrows here. This is called a triangular prism. All right, and it's called a triangular prism because the base and the top and the bottom, or the 2 bases are triangles. The 2 special sides of it are triangles, right? This one and this one are both triangles, but then it's connected by rectangles. So that's why we call it a prism, a triangular prism. Okay, now we'll just go through that. There you go. And last, what I want to do is I'm going to run out of time on this video. Okay, I'm going to go to this slide.